computation. I'm just going to tell you guys the answer, all right? But here's the thing. If you want to integrate sine x over x, yes, you can say si of x, but it's not really going to be helpful in terms of coming up with the final numerical value. And the problem with this is that we have this double integral with x going first. So let's try to change the order of integration. But you have to be really careful of the region that we are dealing with. If it's a rectangular region that we are integrating over, then we can just change x, dx and dy, that's no problem. But if it's a function here, then I would recommend you guys to sketch the region and then do the following. So check this out. All right, x is equal to pi y. So right here, x is equal to pi times y. Okay, so we look at this, and then we go to x is equal to pi. So we have this right here, and then x is equal to pi, let's say it's right here. So it's a vertical line. Don't forget this is x equal to pi. And then next, we look at dy. So I'll put this down in red. Yeah. If we look at dy, y goes from 0 to 1. So this is y equal to 0. Right, y equal to 0. I'll put it down right here. And then, of course, you can double check. This right here will be y equal to 1. So the region that we're talking about is this bottom triangle here. Anyway, this is like a function. It's kind of like you have a function like right here, and then you're trying to find the volume. It's 3-dimensional, that kind of thing. Okay, so what do we do? Okay, originally, we go horizontally, right? We have this to that. So now we have to look at this vertically. So we draw a vertical rectangle because we want to go with dy first. So this right here, I want to have dy going first, and then dx, and then dx will be it's black. And the function inside does not change. It still does a function right here. So we'll still have the sine x over x. So if we have the dy right here, integrating that, it's so much easier because x is like a constant in the y world. I'll show you guys how to integrate that in like a second. But how do we do it though? As I said, we draw a vertical rectangle. So look at this right here first. For the blue part, you see y goes from 0 from the bottom. And then once we reach to the top, this y value, well, is this equation. We will have to isolate this y, and y equals 1 over pi times x. And I will just write this. 1 over pi times x. So that's that. Then for the x part, well, it's still going from 0 to x. That means 0 to pi. You see? dx, you start with this x value, ending with this x value. So we still go with 0 to pi. So that's that. Now let's integrate this. Very easy. Outside, you keep it, integral of going from 0 to pi. Inside, we have sine x over x. In the y world, you just have the y here. That's it. We go from 0 to 1 over pi x, and then dx after that. So let's go ahead and do it real quick. Put this in here, we have x over pi. So let me write it down for you guys. This is integral going from 0 to pi, sine x over x, and then we have x over pi. Yeah, and then plugging 0, we just get 0, so this is okay. So we have dx. Guess what? This and that cancel. And we will get 1 over pi at the front, and then integral going from 0 to pi, sine x dx. Right, work this out on your own. This is 1 over pi times 2, so we get 2 over pi. Yeah. If you look at this right here, can we integrate cosine y in the y world? Yeah, that's pretty straightforward. So let's just do it. So right here, we have the integral going from 0 to 1. Integral of cosine y is positive sine y. And then we will just have to go from inverse tangent of x to pi over 4 and then dx. So this right here, we get the integral going from 0 to 1, and then we have sine of pi over 4 and then minus sine of inverse tangent of, oops, yeah, like that, and then dx. Maybe put another parentheses. All right, so let's figure this out. Let's figure it out and integrate. So here we have the integral going from 0 to 1. Sine of pi over 4 is 1 over square root of 2. For this right here, let's draw a right triangle real quick. So inverse tangent, so x over 1. And then this right here is square root of 1 square plus x squared. So sine of this, where the angle is here, this is the angle, is x over that. So it's minus x over square root of 1 plus x squared. And then we have the dx. All right, integrate. 1 over square root of, just kidding, 1 over square root of 2x. And integrate this, you just do u sub. I will leave that to you. You get minus square root of 1 plus x squared. Yeah, and then you go from 0 to 1. Okay, putting 1, we get 1 over square root of 2. Putting 1, we get square root of 2, so minus square root of 2. So that's the first part. Minus putting 0, we get 0, and putting 0, we get minus 1. So be really careful. I shall just write down the whole thing, 0 minus 1. Yeah. Okay, and then just get a common denominator and all that stuff. So multiply by square root of 2, multiply by square root of 2, and this is 2. But 1 minus 2 is negative 1. The 1 minus negative 1 is 1. And then 1 minus 2 is negative. So yes, this number, 1 minus 1 over square root 1 over 1 plus x to the fourth power is super hard to integrate. You can try it. I have a video on that. I wouldn't recommend you guys do this. So let's change the order of integration. Okay, x is equal to y, so that's just a diagonal. That's good, like that. And then x is equal to 1. So again, it's x equal to y, starting from here, and you move to the left. So we're looking at this region here. Yeah, left to right. And then for y is y equal to 0, and then to 1. Bottom to top, so it's this triangle here. So it was left to right, so it was meant to be a horizontal rectangle first, but now to change the order, we draw vertical rectangle. And I will just write this down. This is the integral. We want dy goes first, and then dx. And the inside is still 1 over 1 plus x to the fourth power. Okay, so if y goes first, then we look at bottom to the top. Bottom is when y is equal to 0. Up to top, top is y equals x. X, 0 to 1. Yeah. Integrating this is very nice because we just have to multiply by an x. So this right here, we get, let me see. Now let's do this on red. 1 over 1 plus, so multiply by y, fourth power, and then y. Yeah, it's just 1. And then, oh yeah, and then we go from 0 to x, and then dx. Put x here. We get x over 1 plus x to the fourth power, and then put 0 here, so it's gone. That's good. So this is what we have. Integrate this. Here's the trick. Integral. Oh, that looks like a super cool x. This is the integral going from 0 to 1, x over 1 plus parentheses x square dx. Do a u substitution in your head. That u equal x squared. We need a 2, so divided by 2, yeah? So 1/2 inverse tangent of x squared. And then in 0 to 1, put 1 in here. Inverse tangent of 1 is pi over 4. Pi over 4 times 1/2 is pi over 8. Divided by, plugging 0 is 0, so it's pi over 8. That's the answer. So again, in this case, it's not possible to integrate cosine to the third power, cosine y to the third power in the usual sense. So again, let's change the order integration. So let's look at the region. Here, y goes first. So y is square root of x. So we look at this right here, y is square root of x. And then from bottom to top, right, because we have y, so this is the bottom, and we go up to top. So we go like this, y is equal to 1. Okay, so bottom to top. And then we look at the x, which is right here. X is 0, and then this right here is x equals 1. So it's this region that we're talking about now. Okay, so it really depends. Be really careful. It's not this, it's that. All right, so how do we change it? If we want to change the order of the integration, then we switch this. We want the dx go first and then dy. If dx goes first, that means we want to look at this from left to right. So we want to draw a horizontal rectangle. That might be helpful. Okay, so x starts with 0. That's good. But you see, this rectangle, it changes the horizontal length, right? And that changes y equals square root of x, meaning x is equal to y squared. How about y though? Y goes from 0 to 1. Nice. And then the function stays the same. We have cosine of y to the third power. Integrate this real quick. Let's try this. Let's integrate this in our head. This is a constant in the x world. Integrating this, we just put the x. And then, oops, sorry. It should be y here. It should be y here. Put the x here, and then integrate, plug in y squared. So we will first have y squared and then cosine of y to the third power, yeah, and then plug in 0, it's just 0, that's nice. And then we have the dy here. Now, for this, let's just do a u sub. Let u equal y to the third power, so we need 1/3 here for the result of integration. And then the integral of this is sine, and then we have y to the third power. And then we plug in 0 to 1. So, ladies and gentlemen, 1/3 sine of 1. If you would like, yes, you can use the reduction formula that we did earlier today to integrate secant to the 5th power of y in the y world, but let's not do that. Change the variable, change the order. Okay, let's see how it goes. So firstly, I will have to draw y is equal to the inverse tangent, so it looks like this, right? So I'll just say like, it has a horizontal asymptote, so this is y equals inverse tangent of x. And then y equals, so this is the bottom, to the top, y is equal to pi over 6. Let's say this is pi over 6. 0, and this intersection, you can verify on your own, it's indeed 1 over square root of 3. Okay. So it's this, bottom to the top, so it's like that. And now we'll change order, so horizontal rectangle right in here, and let's just this, and then secant to the 5th power y, it's wrong color, secant to the 5th power y dy. dx. No, I have dy dx already. What am I talking about? Dx dy, sorry. Dx dy. Here we go. Dx. So from left to right, horizontal rectangle, start with 0. This is this function, meaning just go ahead and do x equals tangent of y. So here we have tangent of y. And then y goes from here to here, so it's 0 to pi over 6. Now, if is this any better? Yes, it is. Trust me. Here, integrate this thing in the x world. And yeah, let's just do that. We just put x, and then we put a tangent, yeah? So first we have 0 to pi over 6 still at the front. And then we have secant to the 5th power y times tangent y. And the plugging 0 is just nothing, so that's what we have. So we have the dy here. How do we deal with this though? Let me tell you, put out a secant. So here, integral going from 0 to pi over 6. Secant to the 4th power y, and then let's have secant y, tangent y, dy. Put u to be secant y, derivative here is that. So we can see this is 1/5 secant 5th power y, and we go from 0 to pi over 6. What's secant of pi over 6 though? Okay. Pi over 6 is 30 degrees right here. And then we will have 1 square root of 3 and 2. And secant is this over that. So we are going to get 1 over 5. And then 2 over square root of 3 to the 5th power. That's the first term, yeah? And then minus, put 0 in here. We get 1. So it's 1 over 5. Secant of 0 is 1. 5th power is 1, and multiply by that. Okay. Finally, we just clean things up. 2 to the 5th power is 32. Square root of 3 to the 5th power is 3 times 3 is 9. Because 2 of the 3 come out. So 9 times 5 is 45. And then 1 more square root of 3. And then lastly, minus 1 over 5. Okay, so shall we change the order of integration? No, we don't have to. Oops, sorry. Dx, dy. So dy, dx. So we change the order of integration. Let me tell you, no. Here, we can integrate secant square y in the y world easily. This is just a constant multiple, leave it. Right, leave it. So here, we are going to get integral going from 0 to square root of pi over 2. This is going to give us tangent y, and then let me just have x times tangent y, and then keep in mind y goes from 0 to x squared here, and then here we have the dx. So put the x squared and then put that. So here we get the integral going from 0 to square root of pi over 2, and we have x times tangent y is now x squared, and then plugging 0 into the y is just 0, so that's nothing, and that's pretty much it. Then we can do a u sub, right? So that u equal x squared, and yeah, and let me also remind you guys the integral of tangent u du is ln up to the value of secant u. Why am I telling you guys this? I did this earlier too. So let me erase it. Alright, just do a u sub on your own like that, and we'll end up with 1/2. Integrating tangent u, we get ln, no need for absolute value, just parentheses, secant u, which is x squared. Alright, and then we go from 0 to square root of pi over 2. And we get 1/2 ln parentheses secant of square root of pi over 2 square, like this, like that. And then minus, put 0 in here is 1. ln 1 is 0, so we don't have to worry about it. And then here inside is just secant of pi over 4. So this is 1/2 ln secant of pi over 4. And what's ln of secant pi over 4 is square root of 2. So this right here is 1/2 ln of square root of 2. And square root is the same as 1/2 power. 1/2 can be brought into the front, so we have 1 over 4 ln 2. Yeah. Alright, so same thing. You don't really have to change the order of integration. So I'll just integrate it. Here we have going from 0 to 4 first. This is just a constant, yeah, so just keep it. 2 over y plus 1. Just leave it like that. No problem on it, okay? And then integrate ln, integrate x plus 1 is ln, so it's ln, and we don't have to worry about its opacity, so x plus 1. Yeah. Okay, and then we go from 0 to y in the y world here. Y goes in here first, so we have integral 0 to 4. Let's put a 2 at the front, yeah? And then ln of y plus 1 over y plus 1. And then dy. Yeah, put the y in here. So that's what we have. And integrating this. Alright, so this right here, I'll give you guys a little hint. We let u equal to ln of y plus 1 because du will be 1 over y plus 1 dy. So in fact, we are just integrating u in the y world. So we get the 2, and then integrating u is u squared over 2, right? So the 2 cancel out. This 2 cancel out. Now this 2 is no more. Now this 2 is no more. But it's just going to be ln of y plus 1 to the second power. And then we go from 0 to 4. So put a 4 in here. We get ln of 5. And then square, put a 0 in there, it's just nothing. So ln 5 squared. Okay, for this one, I just want to show you guys what I mean by you can change the order of dx dy if the region is a rectangle. Notice we have dx dy, yeah? So x is going from 0 to pi. And then square root of pi is smaller, so let's say we have it from 0 to square root of pi. This is x. This region. If you would like, this is actually the same thing as we integrate x first. So I will still write this down inside. Okay, sorry. And then y sine of x plus y squared dy dx. You can switch this. Dy can be inside first, like that. In that case, you just put 0 to square root of pi. And then if you look at x, you go from here to here, which is 0 to pi. It's a rectangle. You can switch it without any worry. When you have functions, when you have curves, be careful. Alright, but the truth is, for this one, we don't have to switch the order. In my opinion, they are the same. They are about the same difficulty. So let's just integrate inside one first. Integral 0 to square root of pi. Integrating x, y are just constants. So we get negative cosine. So the y is a constant multiple, we keep it. and then integrate sine, we get negative cosine, and we have x, and the derivative x plus y squared just 1, so nothing else we have to worry about. So this is the integral for that, yeah? And then we have to plug in numbers, 0 to pi dy. And be super careful, we are in the x world, so this right here, we have to put it in the x. So 0 to square root of pi, put pi in x, negative y cosine of pi plus y squared. And then put 0 in here. Oh, and let's see, this is like this, and then minus negative y, put 0 in here, just cosine of 0 plus y squared. Don't need that anymore. Close parentheses, close, and then finally we have that dy. Okay, trig identity. Cosine of, let me write it down to make it more clear. Cosine of pi plus theta equals negative cosine theta. So with that being said, this pi, just keep it and make that positive. So this right here will give us integral going from 0 to square root of pi, y here, and then cosine of y squared. And that becomes positive because of the pi. Negative is positive, and then again another y, and then 0 doesn't matter. So okay, y is 2y, cosine of y squared. We integrate this from 0 to square root of pi dy. The inside here give us the integral of cosine is positive sign, and then it's just y squared. Yeah, we have 2y here already, and then we go from 0 to square root of pi. Put the square root of pi here, sine of pi is 0. Put 0 in here, it's also 0. All in all, we get 0. We're in the y world, can we integrate this part? You know that that's a constant multiple. But let me tell you, it's not possible. So change of variable is the best. Let's see. Y goes from x, right? So y is equal to x. It's this line again. So we go from the bottom, right? Bottom to the top. Y is 2. So this is y equals 2. Y, and then x goes from 0 to 2. So it's this region. Okay, I want the integral, and then integral, and then the inside stays, which is x square root 1 plus y third power. I want dx going first, and then dy next. If dx goes first, we look at the horizontal cut. From left to right, left is 0, right is x equals y. Y goes from 0 to 2. Cool. Now, we have an x here, so this time it's not so easy. We have to integrate x, which is x squared over 2. Plugging y, so altogether right here, we could get 0 to 2, and then we get y squared over 2. Okay, and the plugging 0 is nothing. And then we have the square root of 1 plus y third power dy. And now, put u to be 1 plus y to the third power. Okay, let's try if we can do this in our head. Put y to be y to the third, put u to be y to the 1 plus y to the third power. We need to divide it by 3, yeah? We have y squared already, so we need to divide it by 3. So it's 1 over 6. And then we have u to the 1/2 power. Integrate that is u to the 1/2 plus 1 is 3/2. Divided by the new power, so multiply by 2/3. So it's 1/9. Yeah, so it's 1/9 here. And then we plug in numbers 0 to 2. Just work this out on your own, yeah. So altogether we get 26/9. Yeah, put the 2, but I'll still do it. Put the 2 here. 2 is 8. 8 plus 1 is 9. 9 take the square root of that is 3. 3 to a third power is 27/9. Put 0 in here is 1/9. So 26/9. Okay, number 90, we have this double integral. And of course, if you look at y, and here we have y over L and y, we cannot integrate that. So let's just change the order of integration. So let's look at the region. We are looking at the bottom is e to the x. So you have it like this. And then 2. So let's say it's right here. So this is y equals 2. And this is y equals e to the x. And then we are going from x equal to 0 to ln 2. So it's this region here. Okay. Integral 2x y over ln y. Dx going first, and then dy next. In that case, look at from left to right first. Draw a horizontal rectangle. Start from 0. This right here is the curve. So x is ln y. So I'll put that down right here. And then dy, y is, be really careful. Here is 1. 1 to 2. 1 to 2. So 1 to 2. Okay. Integrating 2x in the x world, we get x squared. So I think I will just do this one in, let's do it like this. Integral 1 to 2, and then we have y over ln y, yeah? This part, so it's constant multiple, we'll write it down first. And then we get x squared. Plug in ln y, so we have ln y squared. All right, and then plugging 0, it's 0, so that's what we have. And then we have dy. This is good, can cancel, and for this guy, we can integrate by parts. So di plus minus, I will differentiate ln y, I will integrate 1. I will integrate y. So this right here will give us 1 over y. I will get 1 over 2 y squared. So first part of the answer is 1/2 y squared ln y minus, multiply this and that. So the integral going from, this is 1 to 2, and then still go from 1 to 2. This multiplies, so we get 1/2 y, yeah, they cancel, so we just have y and then dy. Okay, 1/2 y squared ln y minus the result, the integration here is put 2 divided by that's 1 over 4 y squared, and now plugging 1, 2. Put 2 in here. 1/2 of 4 is 2. And then ln 2. Put 2 in here is minus 1. Put 1 in here, that's 0. Put 1 in here is minus 1 over 4. It's a minus 1 over 4, so like that. So all in all, we get, how do you write the answer? Oh, just like that. So just 2 ln 2. And then this is negative 1 plus 1 over 4, so it's minus 3 over 4. Okay.